Hi, everybody. I'm so happy to be back in person this year at RubyConf finally, after 2 years of not seeing any of your faces, except for on screens. Before we get started, I want to say thank you to all of the organizers at Ruby Central, volunteers, everybody from Confreaks and doing audio and making sure this conference happens and live stream. After doing several remote talks over the past couple of years, I can firsthand appreciate how much work goes into audio and lighting, and recording and live stream, and I am very glad to not be worrying about my Wi-Fi going out while giving this talk. I'd also like to thank all of you in the audience for coming in person to RubyConf this year, and everybody watching on the live stream at home. I hope that you're all enjoying this conference as much as I am. For those who I haven't met before, I'm Eileen Uchitelle, and you can find me anywhere online at the handle Eileen Codes. I'm a member of the Rails core team since 2017. The core team for Rails is similar to the Ruby core team in that we really work to drive the future of the framework. We plan releases, merge contributions, and build functionality to improve the framework in order to support applications as they grow. I work at GitHub where I'm a principal software engineer. I work on improving the Rails framework and Ruby language so that we can continue to use them for the long haul. Our team at GitHub works to find areas where we can improve performance, and build functionality, fix bugs, and really push the boundaries of Rails and Ruby. In the past year, we've made many improvements to Ruby, including making the super method faster, fixing bugs, updating gems to support Ruby 3, sending pull requests to Shopify's widget, and of course, what we're all here to talk about today, improving the performance of class variables. Earlier this year, I worked with Aaron Patterson from Shopify on adding class variables, adding a cache to class variables to make them faster. On the surface, adding a cache probably sounds like a relatively simple project. However, it took us about 6 months or maybe even longer, I don't remember, and a few different attempts to accomplish this because it turns out that class variables in Ruby are incredibly complex. So today we're going to talk about how class variables work, what makes them complex, why they were slow, and how we made a cache to improve their performance. After diving into the technical details, we'll take a look at what we learned, how to handle trade-offs in open source, and lastly, why it's so important that we all work to make improvements to Ruby. Before we deep dive into Ruby internals and how we improve the performance of class variables, let's first look at what a class variable is and how it works. A CVAR, or class variable, is a type of Ruby variable that is defined on the class level rather than the instance level. You're probably very familiar with instance variables, but you're less likely to have worked directly with class variables. They're a bit different, a bit difficult to reason about, and you'll often be told to avoid using them. Literally every Ruby book tells you to avoid them. Class variables are denoted by 2 @ signs instead of 1. In this class here, we have we are setting a class variable called @CVAR, @CVAR, and we have a method to read that class variable. That all sounds pretty simple, right? What could be so complex about class variables based on this example? Well, you see, class variables get a lot more complex once you look at how inheritance works. To understand the complexity, let's first take a look at instance variables and how they work with inheritance. So here we have 2 classes. Class dog has an initializer with the name instance variable with the value Aria and an owner instance variable with the value Eileen. I do have a dog named Aria, so this is real. Puppy inherits from dog and sets the value of name to Sansa, but does not set owner. When we read these variables in Ruby, we can see that the IVARs are isolated to their instance. While puppy inherits from dog, puppy doesn't automatically inherit initialized instance variables from dog. We can see here that name on dog is set to Aria and owner is set to Eileen. Name on the puppy instance is set to Sansa, and owner returns nil. Instance variables are bound to the cur itself, which in this case is the instance of the class dog or puppy. The instance variables on dog are isolated from instance variables on puppy. Initializing a dog instance doesn't change puppy, and initializing a puppy instance doesn't change dog. If you've been writing Ruby for a bit, you're likely already familiar with how this works, and this isn't surprising. The inheritance model is pretty straightforward when it comes to instance variables. Class variables, on the other hand, behave very differently in regards to inheritance, which can cause confusion around how to use them properly. Let's take a similar example, but with the class variables. In this example, dog has a name class variable set to Aria and an owner class variable set to Eileen. Puppy inherits from dog and sets the name CVAR to Sansa, just like the previous one. So now let's see what happens when we read these class variables. Here we can see that dog owner is Eileen and puppy owner is Eileen. Remember, instance variables puppy was nil. So that's already different. But let's see what name is on dog. Wait, dog name is set to Sansa? Shouldn't it be Arya? And puppy name is also set to Sansa? How can that be? Does this look like a bug? Why would both classes return puppy's values for the name class variable? Well, it might look like a bug, but this is actually how class variables are supposed to work. CVARs are shared among their descendants. So think of class variables as global. They can only have one value for a class in the same inheritance chain, and the last one to set the class variable wins. Every time you write or read a class variable, Ruby will walk the entire inheritance chain all the way up to basic object looking for the topmost class in the chain that sets the same class variable. So if name is set on by both puppy and dog, the actual value of name is stored on dog, which is the parent of puppy. Dog will also store the value of owner. Then when puppy sets the name to Sansa, Arya is going to get overwritten as the value that's stored on dog, because the last class in the chain to set the class variable wins, even though the value is stored on the dog class. That's a mouthful. The information for the class variable value is stored in a hash table, which is accessed on the dog class, since dog is the topmost class that also has a setter for name. Fun fact, class variables and instance variables are stored in the same hash table structure in Ruby. This is possible because the double @ sign is not a valid instance variable name, so IVARs and CVARs will never clash in that table and they can share the same space. You might be looking at this and thinking, well, if the hash table is stored on the topmost class, why don't we just stop at dog? Why does Ruby have to keep going all the way up the chain to basic object every time a class variable is written or read? Well, the reason Ruby needs to do this is to handle what's called CVAR overtaken. Since you can reopen classes in Ruby or mix in modules, Ruby cannot be sure that there isn't already a class variable with the same key set elsewhere. So every time a class is called, Ruby has to check the entire chain for an existing hash table, and if it finds one, it's going to raise an error. Let's look at an example. Here we have the dog defined without a class variable, and puppy class defines a name. In this case, the class variable hash table is going to be stored on puppy, not dog, because dog did not set a name class variable. We then reopen the dog class and define a name class variable in that class. When our code tries to read the name class variable on puppy, it's going to raise an error, class variable name of puppy overtaken by dog. What's happening here is that when the name CVAR is set on dog, the hash table that was stored on puppy gets overtaken because the class was reopened. The class variable needs to be stored on the highest class in the chain that has that class variable. So when puppy name is called, the hash table that was stored there is effectively broken because we reopened the dog class and set the name class variable higher up. So as you can see, class variable inheritance is incredibly complex, which is one of the reasons it's such a disliked feature by Rubyists. Now that you understand how inheritance and overtaken work, you're probably not very surprised to find out that the overtaken check means that class variables can be pretty slow. In fact, the deeper the inheritance chain, the slower it will be to write and read class variables. If you have 100 classes in your inheritance chain, Ruby is going to need to walk all 100 classes plus the ones up to basic object for every single class variable you write or read, every single time. So let's take a look at some benchmarks to see how slow it really is. Here we have a script that generates a list of letters that we can use for module names. Class 1 here includes 1 module, we have a second class that includes 30 modules, and a third class that includes 100 modules. In this example, we're using modules instead of classes, but the inheritance behavior is exactly the same. Then our benchmark reads the CVAR getter from each of our classes to demonstrate that when the inheritance chain is deeper, class variables get slower. Who wants to see the numbers? In Ruby 3.1 at the time, including 30 modules with a class variable was 2.8 times slower than including 1 module, and including 100 modules was 8.5 times slower than including 1 module. That's a pretty significant difference. It's clear that you don't have to worry a lot about class variable performance if you only have 1 class in your inheritance chain. But if you have 100 modules or classes, the class variable behavior is very likely affecting your application performance. Okay, but how often do we actually have a deep inheritance chain that's using class variables? When working on improving performance, it's important to realize that a micro benchmark like this that shows an improvement might not actually translate into meaningful performance improvements in your application or library. So once we knew how slow class variables were, the question became, how often are class variables used? And when they are used, how often is the inheritance chain deep enough to warrant fixing the performance of class variables? It's not going to be worth fixing performance if no one ever uses them. So while you may not use class variables often in your code because you're told not to, you might be surprised to find out that Rails uses class variables extensively for application configuration. One of the most well-known variables is class variables is probably active record-based configurations. This class variable stores all of your database configurations for your Rails application. In addition, anytime you see matter accessor in Rails, it's actually a feature of Rails that creates a class variable. It's DSL, you can't really see it, but if you go deep in the code, you can see the class variables. So it wouldn't be a big deal that Rails uses class variables if the inheritance chains are super short, right? So when you look at the ancestors of a few key classes, we can see that Rails inheritance chains are often quite deep. In a vanilla Rails application, and I did not look at this in GitHub, so it's probably worse. Active Record has 73 ancestors. Action Controller has 71, and Active Job has 29. And all three of these use class variables. And I didn't check the other libraries, so it might be even worse than that. This means that if you're using Rails, the performance of class variables is likely affecting your application performance in a very real way. In order to address this, Aaron Patterson and I set out to build a cache for class variables. When Aaron and I first started working on this, we didn't realize how complex class variables were, at least I didn't. So it took us a really long time to figure out exactly how the code worked and where all of the issues with overtaken were. So while it was a difficult project that took us a really long time, we wanted to pursue it because we knew that class variables were slow and that their slowness was affecting every single application. If we could make class variables faster, we'd make Ruby faster. If we make Ruby faster, we make Rails faster. And if we make Rails faster, we make our applications faster, and then your application faster. This was an opportunity to improve the performance of every single code base that uses class variables. So as we saw earlier, class variables are stored on a hash table on the highest class that's set, the CVAR. So it made sense to store the hash table for the cache next to the class variable hash table. Then we could lean on the existing class variable code and handle creating and busting the cache alongside it. So the cache hash table holds the class variable name, which points to an inline cache. The inline cache is a pointer back to dog and tracks a value called global CVAR state. The cache is stored on the topmost class, so when puppy needs to find its class variable, the cache will be created by dog. The first time we read or write a class variable, Ruby will walk all the way up the inheritance chain looking for the topmost class that has a setter for the name class variable. While doing this, an inline cache is created, and that inline cache is stored in the bytecode so that puppy can access it when needed. The next time we read or write the class variable, Ruby will use the cache to do the lookup instead of walking up the chain. So for example, when we call puppy name in an application, Ruby will find the global CVAR state from the cache and compare it to get global CVAR state value. If they match, that means that we've seen this class variable before and our cache is good. The cache then returns the dog class, which informs Ruby where to look up the class variable hash table. That means that we don't have to go up the chain again. We know exactly where the hash table is stored. And then the value so-and-so will be returned from the dog class's IV table, hash table. This allows Ruby to entirely skip walking the inheritance chain once the class is created. In the case of overtaken, global CVAR state would have a different value for the get global CVAR state, and then in that case, the cache is ignored. If those values are different, Ruby will then walk the ancestor chain and build a new cache for the next time. And that's basically it. As you can see, the overall cache ended up with a relatively simple design. I'm not going to show you the C code. It's really not that interesting. But if you're really interested in seeing it, you can find the PR on GitHub. While the cache ended up with this relatively simple design, it took us a really long time to get a good handle on how class variables work in Ruby. The majority of our time was actually spent tracing the code through, and like every time we would pair again, we'd be like, how do they work? Okay, we have to write it down eventually. Or maybe I wrote a talk, so we'll all remember now. When we were done adding the cache, it was time to run some benchmarks to see if our cache was faster. Remember, just because you think you improved performance doesn't mean you actually did. So it's important to always benchmark your changes after you're done. So let's revisit the benchmark from earlier that showed that including 100 modules that read a CVAR was 8.5 times slower than including one module. When running the same benchmark on our branch that added the cache, we saw that we completely eliminated the progressive growth that occurs as more classes are added to the inheritance chain. Now including one module with a class variable, it has the same performance characteristics as 100 modules with a class variable. While this benchmark showed a massive improvement in performance, it's still considered a micro benchmark, which means that it doesn't represent real world scenarios. We needed a benchmark that was more representative of a real application. So we ended up measuring the performance with Railsbench, which is a Rails application that can be used to measure requests per second in a more production-like environment. I mean, it's definitely not as good as running it on like GitHub production hosts, but it can tell us a lot more than micro benchmarks can. So with Railsbench, we saw that Rails 6.1 with a class variable cache, without a class variable cache, could perform 615 requests per second. Then we did the same measurement using our CVAR cache branch and found we could perform 657 requests per second. With that, that means we're getting 42 more requests per second, which works out to about 6 to 7% improvement in request times. These benchmarks demonstrated that the CVAR cache is faster, not just in micro benchmark scenarios, but will have a real impact on application performance as well. So through this work, Aaron and I learned a ton. At first, adding a cache to class variables seemed like a relatively simple task, but when we first started working on this project. But as I mentioned earlier, it took about 6 months to actually get something working that we were confident was, well, not full of bugs. I remember at one point we thought we were ready to open the PR for the cache, and Aaron had a dream that we had a bug in the overtaken behavior, and it turned out he was right. The complexity of class variable inheritance was why making this change was so difficult. So we finally got the bug fixed, we got the test passing and diagrams made, and we were confident our changes were good. We opened the pull request and the feature request issue and waited for commentary. After some discussion on the issue, I started to get really nervous because it became clear the Ruby team wasn't sure they wanted to merge the feature. Of course, everybody appreciated our hard work, but like I said, CVARs are very, very complex. And by adding a cache, we increased that complexity. Eventually, we did get it merged, but I want to take some time in this talk to dive into what concerns the core team had and how we navigated negotiating getting this change merged anyway. Fundamentally, every change in open source has trade-offs. Actually, let's be real, every change to code everywhere has trade-offs. I'm sure you've experienced this at work in your own job trying to decide whether it's worth the risk of fixing that technical debt or just ignore it and build your feature. Maybe you opt to add complexity because you think you'll get back to fix it later, and you never do. Maybe you decide to not remove that out-of-date gem because you don't have time, or maybe you write a monkey patch in your application instead of sending an upstream patch because you didn't want to wait for a release. Every day we weigh trade-offs in our code regarding complexity against one another when making changes to our code base. Open source maintainers have to do the same thing. They need to weigh the trade-offs of whether a change is worth it or not. To Aaron and I, adding a cache seemed like a clear win. Class variables are slow, we made class variables fast. So objectively, adding a cache is a net win, right? What trade-offs could there possibly be when we fix a performance issue in Ruby? When you have a feature as complex as class variables, any change, even small changes, have trade-offs that maintainers need to consider. The first trade-off the core team was concerned about was that our change increased complexity of class variables. As you saw today, CVARs are already super complex. So by adding something even as simple as a cache, we made them even more complex. And now in addition to inheritance and overtaking complexity, we've introduced the complexity of creating, updating, and busting an inline cache. When the cache was done, it seemed simple to us, but the process to get there demonstrated that it's really just not that straightforward. To accomplish adding a cache, we have to add a second hash table, track every time we write a CVAR, and ensure that cache behaves properly when class variables are overtaken. CVAR behavior around inheritance means that there's a lot of places that we could have gotten it wrong. We had to be absolutely sure that we covered every case for when a class variable can be set in Ruby code. Another concern the core team had was that we were going to encourage more people to use class variables by making them faster. As I mentioned earlier, it is not a well-liked feature of Ruby, not even by the language maintainers. Some people consider them so confusing to use correctly, they might as well be deprecated. The concern was if we made class variables faster, then we'd accidentally encourage applications and libraries to use them more. And since most Ruby programmers aren't aware of the intricacies of class variables, encouraging more usage might lead to increased bug reports on the issues tracker or other efforts to make them better. If we keep making them more useful, then they're harder to deprecate in the future. Lastly, by adding a cache to class variables, we increase the maintenance burden for the core team. What if a new case for inheritance is added and we miss clearing the cache? What if there's a bug in the existing code and we're now hiding it? What if we're caching the wrong information in specialized edge cases? And what are the risks to existing applications? For perspective, consider your application at work or a library that you maintain. Is there a feature or part of the code base that you know better than anybody else? What if someone came along and changed all that code? How would you feel if you knew it was probably a net gain, but now you don't understand all the moving parts? I've experienced this myself as a Rails maintainer. I want contributions, but I don't want to introduce changes I don't understand, because once it's merged, that responsibility becomes mine. So I completely understood where the core team was coming from, even though I felt that adding a cache was a net win. So once we understood the concerns of the core team, we had to convince them the change was worth it. Negotiating whether a change should be merged is a tough thing to do, but it's an important skill for contributing to open source or really anything at work that you're doing ever. First, we pointed out that class variables are not deprecated, and they are unlikely to be removed from the language even if they're an unpopular feature. While they are complex and have strange semantics, there are some cases where they are the only feature that we can use. A good example of this is the Rails database configurations. We can't use an instance variable for those. It should be global. There should be only one value, and we should not be allowing other things to change that value. Using an instance variable in that case would break the contract that Active Record relies on. In addition, the benchmarks we provided showed a real-world impact to applications. It wouldn't have been convincing if all we had were micro-benchmarks that showed an improvement to class variables in isolation. By doing the work of getting a benchmark that showed improvements to request times in Rails applications, we were able to show that the cache was effective in making request times 6 to 7% faster. The benchmarks are compelling because they demonstrate real-world improvements, making the complexity worth taking on. Lastly, one of the net benefits of making this type of change to Ruby is that all applications and libraries get a performance boost without changing their code. All they have to do is upgrade. This is compelling because if Ruby is slower, less applications will upgrade. But if Ruby is faster, more applications upgrade. Also, it's more enticing to upgrade if you don't need to do any work to get a free performance improvement. With these 3 points, we had convinced the Mats and the Ruby core team that it was worth trying the class variable cache in Ruby, and it was merged in June. And I guess it was released in the preview this week, so you can all try it. Negotiation isn't about being agreeable all the time or acquiescing to what a maintainer wants. It's about understanding the concerns that they have and working to demonstrate the value of your change around those concerns. When you're negotiating with others, take time to understand the concerns that maintainers have because they end up maintaining that code. Those concerns are valid. Take time to consider how you can make the change less risky or complex and think about how you can prove the change is a net gain even if there's more complexity or maintenance burden. Be sure that you're willing to do the work to advocate for your change and provide evidence that any added maintenance or complexity is worth that cost. And so I hope that learning about our journey to add a cache to class variables in Ruby has inspired you to contribute to Ruby in the future. I want us to contribute more to Ruby because this is how we maintain a healthy ecosystem for years to come. If you're all worried about Ruby becoming less popular or dying, then the best way to prevent that is for us, everyone here, to start contributing to Ruby. Let's work on making Ruby better so that applications that can not only run on Ruby, but can thrive and scale on Ruby forever. I know firsthand that contributing to open source is a little scary, so I wanted to take a bit of time to talk about how you can start working on Ruby as well. So the first thing that you should do probably is learn C. I'm not a C expert, so while writing this talk, I actually had to go back and reread the cache code like 800 times to figure out how it worked. I wouldn't even really call myself a beginner C programmer. I'm more like a C tourist, visiting it when I want to work on making Ruby better. So you don't have to be a C expert, you just need to learn a little C. Because guess what, Ruby is written in C. And now a little assembly, so you can learn both. So the more C you know, the easier it's going to be to figure out how to change internals. In addition to learning C, you're going to want to get an understanding of how Ruby is designed. For that, I recommend reading Ruby Under a Microscope by Pat Shaughnessy. The book dives into some of the design of Ruby's parser and VM and other areas that make the language unique. The book was written in 2013, so some of Ruby's internals have changed since then, but it's still an invaluable resource for understanding how Ruby was designed. And the fastest way to start contributing to Ruby is to start contributing. That sounds kind of simplistic, but it's also true. Like, you can't contribute to Ruby by thinking, I'd love to contribute to Ruby. You have to do it. Making changes to a programming language that's used by hundreds of thousands of web applications is overwhelming, but contributing to Ruby doesn't mean you need to go implement a new JIT to make Ruby better. You can make small changes like documentation updates, fixing bugs you find on the issues tracker, or by benchmarking and improving performance. I've heard people say things like Ruby is slow because it's Ruby, but really if there's something slow about Ruby, it means that nobody tried to make it faster yet. So the person who can make it faster might be you. I hope this talk has inspired you to contribute to Ruby and look for ways that you can make the language better. When we contribute to Ruby and make the language better, cleaner, and add features, we're making Ruby better for everyone. But we're also making Ruby better for ourselves. Every change to Ruby is for everyone in this room and everyone at home and for you and for me. Contributing to Ruby isn't charity and shouldn't be treated that way. It's not a donation to the community, and I don't do it just for fun. But it is fun. But I contribute to Ruby so that I can thrive as a language. I do it so that GitHub can run on Ruby for 5, 10, 15, 100 years. I do it so Shopify can run on Ruby for 100 years. I do it so your application can run on Ruby for 100 years, and yours, and yours, and yours. I want you to contribute to Ruby for the same reason, to ensure that it can support and grow and scale your application for 100 years. Ruby can't disappear if we don't let it. And Ruby can't go anywhere if we're actively working on making it better. So let's go make Ruby better together. I don't think I have time for questions, so ask them on Discord and I will answer them later as the day goes on.
All right, thank you, Eileen.
Thank you.
Yes.